Hey everybody, it's CT. I had a watcher come in a little earlier and tell me about a whole bunch of stuff. Well, really the main thing that is that I'm using sockets, and he recommended that I use TCP client. And at first I was like very kind of maybe a little snobby towards it, and thinking, man, I don't want to use something that's not going to give me as much control. But then as I kind of thought about it and looked at the implementation, it has one really nice key feature which might be worth looking into, and that is on receive you only get that one packet, so you don't have to worry about like parsing and doing all this crazy stuff. So that is here on the game network. So I kind of just want to see what my implementation of client and server was here. So client, what happens? So yeah, these things are okay, except now I might not need to use these socket async event arg. So yeah, I don't know. I'm gonna pop up an example TCP client server here, and maybe not using that same thing. Okay, TCP client server. So that'd be a TCP listener. So how's the read and the write work? Really, that's what I want to know. So if I go TCP client, just go to TCP client, this thing. How's this work? Num num. So that's not exactly what I want. To get stream though, so definitely want to use that network stream. So let me look into that network stream. Oh, and let's get my dashboard going. Hey Bandboy, probably be streaming for an hour, maybe two. Depends how fast I can get through this. Okay, so let's begin read. So where's my example? Here we go. Begin read. Callback. Okay, okay. So buffer offset size, callback. Oh man, that's too bad. I'm sorry to hear that, Bandboy. Yeesh, brain vessel burst. I wonder if it was like a prior condition, or was it like some kind of stress? But yeah, see you, man. Go see it. See your buddy. Be there for him. Ugh, yeah, smoking. Alright, man. I hope I'm good health from here on out. So here is the async callback delegates. Yeah, see you, man. Okay, Okay, okay. Hmm. I am now thinking I async results. Okay. So, looking back at this, at the begin receive, or end receive, what about end receive? That would be a better one to look at. End read. Yep, so that's my read callback. Network stream. I'm gonna try to get both functions up on there and just see. So we got so we got read, and then we got end read, wherever that is. End read. Begin read and end read. Okay, so begin read. Just does that, and end read. Okay. So here's my buffer. Here's complete message. Number of bytes written. My network stream. Right. And read. And here's the results. Okay. And so the completed message is going to be the concatenation of my complete message my read buffer 0. So yeah, I see that we made this new read buffer, but how does where does this get populated? My completed message. You got number of bytes written. My completed message is my complete message, which right now is blank, and the encoding of my read buffer, which is right now yeah, I don't know. Let me kind of zoom into here. So looking at this code, I got a network stream, and this is what it is. Read buffer, we just make a whole new byte buffer. So we have a new byte buffer and a new empty string and a number of bytes to be read. And then we just say, hey, number of bytes read is my network stream dot end read AR, right? And so then we're just gonna get a string from the buffer, which is just an empty array, 0 and number of bytes written. So I wonder how that works. I guess I don't know if this should be here, is what I'm trying to say. I understand it being here. I think this, instead of saying new, should be like AR dot something. Anyway, um, message received may be larger than buffer size, so loop through until you have it all. Or maybe this needs to come down below this part. I think that's what happened. Alright, anyway. I wonder if there's like comments or anything. Okay. So I'm going to, I guess, modify the clients and the other stuff a little bit. This is going to be a little painful, so I'm going to just make a new folder and do it there. So let's, how do we do this? Go here, add a new folder. Let's make this simple. Let's make this simple, right? Just like I want to do. Alright, so I'm going to add a new item. It's going to be a class. It's going to be called client. And it's going to be in, yes, Unity Shared Network, simple. Instead of shared network, what I might call it is network engine. Or game network, yeah. Game network. Simple. Let's go to properties. Let's make sure you're game network. Game network. Okay. Save it, close it. Alright. This client is going to be simpler. I do think we should have some of the stuff I had on the other client. So let's open up this base client. So I do like these events. And I'm going to just make them actions for now until I realize what I need to make happen here. Okay. So my client's going to have these events. And I'm going to use this this class, which is what? Not the network stream, the thing before the network stream. TCP client, yeah. So let's see. Okay. Let's make this a TCP client up front, but it's not going to be. So if I said TCP client, and I just said client equals new TCP client, or what else do you got? I saw you had some overrides. Address family, yep. Ooh, I like that. Host name and port. So let's just do the loop back and the port 23, why not? So that part is fine. Stream is going to equal clients dot get stream. Alright, cool. So now we got a stream. And all I'll do here is we'll have their events like a client can public void send, and I'm just going to say a packet. I feel like I'm just reinventing everything, but I am making it simpler. How do I really want this to work? This is my chance. This is my chance to make this work exactly the way I want it to work. So this is what I'm trying to do. Alright, sorry. Send, receive. Like, this is what a client does, right? Just sends and receives and disconnects, right? Connects. Public void connect. So this client and my other client are just about the same. So you connect, disconnect, receive, and send. Now, public bool is connected. Alright. I'm really not sure whether I should continue on with this or not, just because I already have something in place, and this is just going to be something else. I guess what I really want to know is, how do I, not doing this at all, I'm more interested about the serializing, not the server. So I am going to delete this stuff right quick. So all of this, delete. Okay. And hopefully all that goes away. And it does. Alright. Here's what I want to do. Let's just say I have a new item, and let's just call it whatever. My special class. And I want to make this a serialized class. So if I made this serializable, and then it has some features like public string name, public float, test, or what about this? Public vector. No, let's just do float. X, public float Y, public float Z, public float R. Alright, so we have a few floats, right? Maybe public int instance ID, public, what else can we do? We got an int, we got some floats, we got a string, and something else, like a list of something else. A list of ints, numbers, and a public. We'll leave it like that for now. So equals new list of ints. Okay. So that's my special class. It's serializable. Alright. In my example game, if I don't do anything else, like if I don't read, don't do that, and all I do is do what? Binary. Is it binary formatter? B equals new binary formatter. What's your override? Alright, I won't worry about it now. B dot serialize. Alright, how do I serialize? That's what I want to know. Serializing. Serialize, here we go. Yep, so C# serialize object. Here we go. So I have some kind of serial object, and yeah, let's make a new object of it. So let's just say my special class C equals new my special class blah, and then we can say C dot name equals test case, C dot instance ID equals 22, C dot X equals 1, C dot Y equals 1.2.345 F, C dot Z equals 100. Let's go something crazy like float dot positive infinity, and then C dot. So you got instance name numbers dot add range new int. And I'm just gonna add some numbers. Alright, so there we go. I have name, instance ID, XYZ, and numbers. So if I look at that, I got name, XYZ, instance, and numbers. Alright, cool. So I have this object that has all these different things, and I want to serialize it. So what do I do? So I can say format. Okay, so I need some kind of stream and an object. Okay. So what kind of streams are there? Stream reader. S equals Alright, so b.serialize, and then we need some kind of stream. Let's see what the C# streams are. C# stream. Maybe it'll tell me who inherits from you. So yeah, we got Oracle, SQL, buffered. What about a memory stream? That sounds good. Memory stream m equals new memory stream and then there's some kind of buffer. Alright, maybe I can just do capacity and say 1024. Alright, so let's put it in a memory stream and let's put C. Alright, so I put it in a memory stream. What do we do now? And then you can close the stream. And then what do we do? M dot what if I said D? Here we go. I'm going to call this input object. Is all of that. That's input object. B is the binary formatter, so BF binary formatter. M is the memory stream, so I'll call it memory stream. So binary formatter is going to deserialize to an object. This object is going to be a my special class, and I'm going to say my special class output object equals this. And let's see what happens. I'm going to step through this code. Yeesh. I have no idea what's going to happen, whether it's going to compile, because I haven't checked if there's any errors. But hopefully there is no errors and this will work. Okay, so luckily it's working. So I have something of my special class. So we have this input object, my special class, and it has all of that junk. So I'm going to hit that, and then when I do that, you can see that it has 22 test case, 9 numbers in there, 1, yep, all good. Okay. So memory stream is, okay, so we got a binary formatter, and a memory stream of 1024. So I don't know what any of this means, but then I'm going to serialize. And so this took 556 bytes, I guess. And then if I F10, all right, let's make a buffer right quick. Byte buffer equals new byte 1024. Alright, cool. So we got the buffer, we got that, the binary formatter. Instead of capacity, we're just gonna put the actual buffer in there, and we're gonna serialize it. bf.close, nope, ms.close And then we're going to say ms dot equals another memory stream of buffer. And then we're going to see if that works. Okay. Hit that. Go through this test case right quick. Memory stream, bf ms close, new memory stream. And we can see output object has all the same stuff. Excellent. So the other thing I guess I want to see is what is the data. So if I hit play, I should be able to see the buffer once I serialize it, I guess. So if I look at buffer, there we go. Let me just kind of guess. I don't know what 0 is. 1, 0, 0, 255, 255, 1. We have another 69 up in there. Alright, well, it works. I just can't tell you how it's working. But it doesn't look too bad. Alright, so that's how you do a stream. So if I didn't do that, and I did something else, like I serializable and implemented interface, get object data, info dot get string, we'll say name, and that would be name or dot set. What do you got? You got a whole bunch of gets. Oh, add value. Info name, info X, Y, Z, instance ID, and numbers. X, Y, Z. Instance ID and numbers. And then you kind of just do that here, right? X, Y, Z, instance ID, numbers. Guess that's what you're showing me down here. Custom serialization. Okay. And a special constructor. So I got the function get object data and a special constructor that will be used. Okay. And basically we're going to be doing this except the other way around. So like get string name, or wait, what do I say? And then we just say name equals that, and then we say x equals get string x. Is that right? And it's not really get string, it's get int32, and it's not get int32, it's get single. Yeah. And then we just do that a few times for y and z. And then finally, instance ID, that's going to be an int, so that's okay. Instance ID info dot get int32 instance ID. And here's the hard one. Numbers equals info dot get. I don't even know. It's not any of that. Ooh, an enumerator, maybe. Get value from numbers. As a list of int. Oh, you need a type. Okay. Type of okay. Maybe? Maybe that might work? Nope. Should just hit F5. Alright, so this works, that works, that works, that works, that works. Already a problem. Alright, unhandle type, let's view detail. Here we go, call stack, line 35. Output, what happened? Or error list. No, the other thing. I missed it. What happened? Oh. Oh, it's not marked as serializable? Okay. That is also a mistake of mine, so let's go ahead and say serializable. And let's start running through this again. Okay, so that's fine. That's fine now. Okay, what about this? Bit of 10. Still 556. And is this using my this? Yeah, so it totally is using that. Alright. So right now info is 0, so if I hit F10, member count 1. So we got 3 members. Name XY. Yeah, I'm gonna run through a few more, so let's go past that. Got current members. Not too worried about the data right now. Okay. Member values, member names. Okay. Well, let me try just one other thing. So say we just made this A, B, C. So if I change just that name, does that lower the amount of bytes here? It does. Okay. So definitely keep the name kind of small. And I don't know if you can even make it smaller than that, like info dot add value. It has to have a name. Okay. No problem. So here's the thing. This one tiny object is going to be quite the handful. So like we did 556 times, let's say we had 10 objects on the screen, so it's already 5K. And let's say we did that 10 times a second. Yeah, that's too big. Okay, so I like where serialization is going, I just don't like what's happening here. Alright. But no problem. What if I made another class? Small packet. And let's say it had just a few things like byte, command, and byte. What else? Small packet, byte command, and byte key. And we made this serializable. And this is going to have to be public. 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 Alright, so we have 2 bytes, and that's all this is. So let's say small packet s small packet equals news small packet, and small packet dot command equals 5, and small packet dot key is equal to 1. Okay. So that's our small packet. Say, okay, that's our buffer. Let's put small packet through here. And then deserialize small packet. Oh, that's okay. Small packet here. Alright, so I'm going to kind of try to run through this. Oh, I just hit play. It's probably going to go right through, no problem. Alright, F10. So my special class, not too worried about it. Alright, small packet, 5 and 1. So if I look at here, 5 and 1, good. Binary formatter, that's okay. Serialize. Alright, so I serialized it. Where are we at? 145, come on. It's 2 bytes. Why is it so big? That's what I don't like. What's our buffer look like? So all of that. Alright, so but there's still stuff I don't really understand. So memory stream, memory stream too big or something. 2 bytes. Or better yet, what other streams do we have? Stream C#. Print queue, network stream, authenticated stream, unmanaged memory stream. So what's the difference between a memory stream and an unmanaged memory stream? Gotcha. What's a pipe stream? I guess the other thing I want to check before I even go a little crazy on this. I should hit F10. Alright, so looking at this, the memory stream of the buffer, if I look at memory stream at this point, it's at 0. Then it's at 145. I guess I just don't like the overhead of it all. Stream overhead, C# stream overhead memory. After generation is fixed. I don't. Yeah, let's see. So now I'm thinking about using my own custom stream just to see if there's like a good, easy way. So if I made my simple, if I made a custom stream .cs and it's public and it overrides, or okay, so let's see what I can do here. I'm thinking about making my own stream, but I just want to see how it's done. So I've implemented the abstract class of stream, and let's see what I need to do. Okay, so flush is actually a function. Okay, so these are all functions now. So these are properties here. So I'm just gonna put you up here. Okay. Bytes dot clear. Alright, this shouldn't be too hard. Bytes dot count. I'm gonna return true. Return true. Return true. I think I'm just gonna say get set. Okay. So that all looks fine to me. Now what are we gonna do here? Okay, for int I equals 0, I less than length, I plus plus, and then we can just say buffer offset. We'll say offset plus I equals bytes I, and we'll just say stream bytes. Okay. For int I equals offset I less than offset plus count I plus plus, stream bytes dot add buffer I. That was easy. Set length. I really don't know. How do I know?